Sure. Great pleasure to be here. Thank you very much for inviting me to the session, and thank you all for attending. I'm Aidan O'Sullivan. I'm Associate Professor at UCL Energy Institute, where I lead a research group in energy and artificial intelligence, which I've led for the last 6 or 7 years, and has been one of the leading groups in the world doing research into the application of AI to problems in the energy space. As part of that research, I've spun out a company called Carbon Re in collaboration with the Cambridge Institute for Manufacturing and my co-founder Dan Somervell, who was a researcher there as well. So we founded Carbon Re because we wanted to make a company that could have impact at the gigaton scale of carbon emissions, and that led us into the energy intensive industries. So how we make cement, how we make steel, and these sectors account for about 20% of global carbon emissions. So really significant global impact, and they require really high grade heat, really high grade temperatures. So the way that we have been making these materials for a long time hasn't changed. And what we want to do is try and incorporate AI into the process and see what can be done to improve that. So we've raised about £5 million in venture capital over the last 2 years. We've done live trials of our technology in a number of cement plants around the world, from Brazil to Vietnam, and we've developed a product that essentially simulates the entire process of manufacture so that we can take what is currently a reactive process and make it predictive. So because these systems are so big, there are tons and tons of material that consume tons and tons of fossil fuels. There's thermal inertia in play. There's all these different challenges for an operator, such as what will the quality of my material be after the process ends, that lead them to make mistakes in how they operate the technology and how they run the process. So we've developed the ability to simulate that process so that thermal inertia and things like this can be accounted for, and so that operators can see in real time what is going to happen in 2 or 3 hours' time in the process as well. So this enables them to use less fuel, less energy to make the same quality of material going forward as well, and have a significant impact on carbon emissions because of the scale of these industries.
And that's exciting, but I'm also curious about how much adoption you're finding. I'll get to that in a minute,
Yeah.
but I'm curious because traditionally the construction industry can be a bit reticent to adoption of new technologies and so on.
Yeah, it's definitely an interesting problem. I could talk about that for quite a while. I mean, there's kind of two sides to that story really. On the one hand, this is a really engineer dominated industry with very technical people who, have very much an engineering mindset and an interest in technologies. And some of the feedback we get is like, why do our factories not look like Elon Musk's gigafactory? Why do they look like they're made from the Victorian times and 70s? And what can we do to improve this? So again, there's huge scope for improvement, and there's a very technical workforce who all have an understanding of AI. Again, AI is so big, it's percolated into the zeitgeist, and everyone has their own understanding of it. When we talk to a cement plant operator in India, he understands AI in the same way that someone in Brazil does, because it's got such a big idea behind it in the space. So on the one hand, it is great to work with people who are really technical and are interested in technology. On the other hand, digitalization and the data space are new concepts in this world. It's definitely behind, say, retail, or behind, say, tech or finance, for example, as industries that have adopted these technologies. So for us, it's a double-edged sword, but we're happy to be working in the space. And in terms of adoption, we've seen it's been really positive in terms of no one doesn't believe in this technology, but then getting in is always a challenge.
That's the digital transformation journey. And I think one
Exactly.
thing I've learned is that one of the biggest problems is not the technology itself, is the people who are sometimes fearful or take a little while to really understand it and adopt it. No, thanks for your introduction.
No, no.
My name is Marco Morales. I'm a innovation strategist at TCS Base Europe, and I guess my job is to look at what technologies are appearing, what are the startups in some ways, but also what are the latest trends and how to leverage them to help large organizations adopt them at scale, at speed, and make the most out of it. And in this case today, we're talking about adoption of AI for fulfilling sustainability goals for businesses, and how to go about it. And for that, we've got yourself. I think we're connecting shortly with Claire Aubertin Noel, who's the managing director and chief of staff of growth markets in Asia, Africa, and Latin America for Accenture. So it'll be really interesting to hear her perspective on this. While we're waiting for her, I think I'm going to go back to your initial thoughts and asking you about what are the challenges that you're finding in the adoption of these things. So if there's anyone in the audience who's trying to either champion this adoption or about to embark on that journey, what are the things to look out for?
Oh wow. Yeah. I mean, being in a startup every day is a challenge, and there's always new challenges to come along as well. I guess in terms of to take it on a kind of positive note, one of the things we got right early on was to just build a prototype, not to kind of go talk to people about the idea, but to showcase things. And it was janky and it wasn't perfect, but we had something. And always, I would say, always having something to show people is kind of your job as an entrepreneur or as kind of someone trying to do innovation. It's not good enough to go to people with an idea. You have to do the work yourself in order to make sure that you have something if you get an opportunity. And again, opportunities will come and someone will know somebody and you'll end up talking to someone that you weren't expecting to, and these things will come along, but you have to kind of do the work to make sure that you're ready for those opportunities. In terms of driving commercial development and commercial adoption of a new technology, it's interesting. You have to always have a champion, and again, there's lots of literature about how you sell new technologies and crossing the chasm and all that kind of good stuff. But generally, you have to really be passionate about the technology, really believe in it yourself, and really kind of see in a kind of a long-term vision for it. You're not really, again, the length of the contracts of these things and the length of the engagements. It's not as if you'll start talking to them today, and a week later, your technology is in their company. It's going to be an order of months, and you have to have a clear vision of what that is.
And
Yeah.
sorry, I'll just step in there because
Yeah.
I think maybe a lot of our audience here also is already those things.
Yeah, yeah.
But then the question might be, who is on the other end listening to this message, and either how do you find the right audience, or who are the other people that you have to convince that really you need on your side, at what level, or who are these champions that are going to help you in your journey?
Yeah, sure. I mean, again, there's always this difference between who's the user, who's the buyer. So our users, in case, don't make financial decisions about what technologies the industry or their company uses. The people who use it are on the ground level using it every day, and their feedback is either kind of positive, it helps my job, or it doesn't help my job. But the act of getting somebody to sign a contract and commercials is a very different kind of conversation, and you have to adjust your pitch and your kind of ideas relative to that. And I think as well, you have to.
Do you still go there with a prototype, or is it a
Yeah.
different?
Well, I think you have to go there with a vision as well. Again, so everyone has this idea of AI, and everyone wants to know what they're doing, their company is going to be doing in that space. So if you can present a clear articulation of why it's important and why they should get involved, and also where it will be in a year, in 2 years, and in 3 years, that's really important, and that helps make the case. Again, it's always good to have the economic argument of this is the payback periods, and there's always the maths you have to do around that to make sure that your payback period is within a year, and all these kind of
So
metrics.
if we go into that space, right,
Yeah.
because it's a big Venn diagram
Yep.
where you have AI, you have sustainability, and it's all in the context of business. So that place where both of them coexist, with where AI and let's say environmental goals and sustainability in general, where they overlap. What are the pros and cons of that overlap?
It's a good question. I guess often what we see from people is a lot of don't want to say posturing, but a lot of uh,
Can we say FOMO? Is
yeah,
that
well,
a PC
road
way of?
mapping, I would say. There's a lot of road mapping about these are our sustainability strategies and this is what we're going to hit, but very little on the how, and a lot of very little on the different ways the technology can impact. So again, we'll often see a company set an ambitious target, but have a very unclear way of getting there. So if you can tie your technology back to that path and back to how it influences and affects their goals, again, it can often be a problem that I see in some entrepreneurs that I mentor, that they're very much thinking about their own thing. And they're not thinking about the problem that they have to solve for the company that they want to work with, for the customer they want to work with. So if you can link how these things fit together in terms of where the company has to go and the threats that they're going to face in the future, because people do think about this again, your job of looking into the future and thinking about the innovations that are going to happen. This is what high level folks do in companies a lot of the time and think about next year and the year after. What will be the impact of CBAM in Europe? What will be the impact of regulations? And how are they going to make their business more sustainable? So again, everyone knows they have to do it, but it's very unclear as to how they should approach that. So if you can present a vision for technology that will help them achieve that, then that is kind of a good way to start the conversation.
So a vision, I can understand that, right? An elevator pitch almost, or something
Yeah.
nice, sharp, straight with a few numbers.
Mm.
And then how do you turn that into something specific? Like, do you have examples of what sort of initiatives or projects demonstrate very clearly what the benefit of AI is within environmental
Of course.
goals?
Again, with any technology, you have to think of the characteristics of it. So AI is a software technology. What things can it do very well that that other technologies can't? So it scales incredibly easily. There's no additive cost or for every single instance. It's one technology. Scaling it is just cloud services extrapolated, and the scaling is far easier than that. So again, that is one way to make it clear of the benefits of the technology in that way for the company. And again, how it kind of fits into their broader vision, their broader strategy is really important as well. So, what is their problem? How is this going to solve it? So, again, what in terms of clear examples, I think again, software adoption is the really great paradigm of once we demonstrate this in one place, it will not be the same cost again and again and again in every place that you want to do it. It will scale very easily, and we'll do a test trial, we'll do a prototype, and then from there it's easy to adopt it again. Now, in terms of kind of clear, specific examples of the use of AI for environmental goals, there's many I can think of. One would be the Learning to Run a Power Network challenge that we did with NEURIPS in 2020. So the French National Grid built a simulator to let companies all over the world develop AI agents to compete to run a power grid more efficiently than anyone else or for longer. And again, it's this notion of running things more efficiently is where AI comes to the fore as a technology. This is what it can do very well. It can, again, a lot of everyone's day-to-day job isn't come in and run things at the absolute limit because everyone comes in and does more or less what they did yesterday. If instead you have an AI agent that's adapting to changes in real time and trying to always find the best answer for today's situation, that is a very different operating paradigm. And I think decision support tools are where AI is going to have the most impact over the next five years in terms of augmenting operators who again are doing very complex jobs and where it's not always clear what the answer is directly, what the best solution is. So again, the ability to simulate 100, 1,000, 5,000 different scenarios and say this is the solution that gives you the best outcomes is going to be transformative on a day-to-day basis for operators.
And is that where the difference is, the clear separation between, let's say, a digital twin and something like generative AI comes in?
Yeah, definitely. Again, a digital twin makes AI so much more usable. Again, we always had this problem with models that they were static, that they never responded, that they drifted over time. And the idea of a digital twin is something that's very responsive to the actual state of a piece of equipment, a piece of factory, an engine, anything. Again, you capture the real-time dynamics of it and you see the wear and tear over time and you adjust what you're recommending based on that. Again, if we use the same models that we developed 6 months ago for a cement plant, we would be making totally garbage recommendations because the whole system changes slowly over time, but noticeably so. So how that kind of difference from generative AI, again, you do have this kind of drift problem in both those scenarios. Digital twins are set up automatically to kind of account for that. Whereas generative AI, you do have that kind of static nature to it still. So again, how you can kind of develop that into solving that problem, I'm not sure. There's a lot of research being done at the moment in terms of not letting things go stupid over time. But digital twins, by their nature, are something that will have more impact in the manufacturing sector, I would say, than any generative AI.
Mhm. And I'm going to take a pause here just quickly. Are there any questions from the audience at this point? Any burning thoughts or things that you must ask? Well, if not, then maybe I'll ask what happens next. So, what sort of what's around the corner from a hopeful visionary position, looking at things if they continue the way they are going. What are the things to look forward to? Let's say in the next couple of years.
So I think we'll need to see a really big shift in what we're doing. So again, all the generative AI, all the Llama, ChatGPT, all that is based on language data. Now, the real opportunity for impact in the environmental and SDG space is in the physical world. What things can we change? What things can we do better to reduce carbon emissions, to reduce environmental impacts? That necessitates working with real world data. And what we're seeing in the AI community now at the very beginnings is an AI for science push. How do we teach physical and chemical laws to AI so that we can do things like simulate new designs for electric motors, simulate new processes for manufacturing different materials, which is our ultimate goal as at Carbon Re as a company. And this requires getting huge amounts of data from physical and chemical processes. Again, that's what these manufacturing systems are. This data exists. This data is out in the real world. This is the data that you have in a cement plant, in SCADA systems, in safety systems. Again, anywhere you have really high degree temperatures, you have to be recording everything so you can see for safety concerns, and you have a closed system. So this is an ideal space for AI to be learning in. And what we hope to see in the future is more application of AI to these problems as we kind of hit the limits of what we can do with natural language processing and all this data that's existed for a long time, from computer vision to all these different spaces. The area where AI really has not broken through is this real world data of what happens when you increase temperatures and you see the effect on different chemicals and you have all that data around their chemical composition. That's what's really exciting to me in terms of the space of AI. And there is starting to be more work in that space from Mila, from Microsoft. A lot of different companies are looking at that space. We're working on it for a very focused reason to reduce carbon emissions and to make materials in the best way that they can possibly be made with the least amount of energy and the highest amount of quality. But in terms of applications of I think in some sense I'm more of a cynic on the generative AI side of things and think the world doesn't need more chatbots. What it actually needs is solutions for problems that we have that are real in the physical world, and that's where you'll make the difference.
However, having said that, generative AI is not just chat, of course, but I think personally what I find really interesting is the advances that are happening in generating 3D from text or from existing video, from photos, creating those shared environments. And I think give it a couple of years, hopefully, I'm crossing fingers here. And if that's the direction it takes, it means that all this data that is from the real world can then be converted into a visualization, a shared space that many different actors can have access to, interact with even, and understand better, bypassing the whole obstacle of translating all these dashboards with numbers in it into something that anyone can understand. So, what happens when not just the people who know how to read those numbers are able to see where are the energy leakages in a building, or where do they need to walk physically to fix something because it's getting too hot in there. It's what happens there.
Yeah, changing the interfaces that we have, which are so limited, would be really significant in terms of how we go about that. Now, how we do that in a trustworthy way is really important as well, because again, the adoption of that technology, would start to, if you remove those screens, then that becomes a challenge of like you're relying entirely on that operating of that AI system. So again, the opportunity to have better interfaces would be really liberating. And again, we can process much more information than we can kind of communicate through keyboards, no matter how fast you type. But that would be an area where definitely there is opportunity for big kind of significant improvements, I think.
I'm going to give everyone again another opportunity. Just think about it for a moment if you have any questions. And in the meantime, I'm going to just mention a book that I love from Jules Verne. So he was a visionary, and one of the lesser known books is Hector Cervedac. And this is the story about a comet that hits a chunk of Earth, and so a whole piece of Earth ends up flung into space. It spends about 2 years going around before it comes back. So I love this story. I read this when I was a kid, and we have so many brains here in this forum today. Now let's imagine for a moment that a big chunk of Earth just got swept off the Earth, spends 2 years out in space, and it has all this brain power in it. And let's imagine that for a moment we've got all the latest AI models and everything we can have. What does it look like when we land back? How has society changed or relationships changed? How has our relationship to the environment and our understanding of it changed? If you remove all the other political obstacles and so on, and you have this control environment where you can do as you want. What is the carbon vision of those 2 years of unfettered access?
Yeah, I think again, any society needs fundamental materials to get going, to get working. We need steel, we need cement to build cities, and all these different things, ceramics, paper. And what frustrates us at Carbon Re in terms of our vision of kind of how things should be is we don't understand those processes very well. We've learned through trial and error over hundreds of years how to make these things, but we don't have a complete understanding of that. And if you can develop that complete understanding of the effects of these physical and chemical reactions, what you can then start to do is completely change the process. Maybe there's a way to make cement that is far less carbon intensive once you can simulate it to a high resolution. Once you have that ability to simulate chemical interactions. For example, one of the latest additives into the mix, it doesn't change anything about cement. It just changes the burning temperature that you need to achieve. So you go from needing 1500 degrees to needing 1300 degrees. Now, that was just by adding in an extra piece of an extra chemical material into the mix. So again, that vision of being able to easily generate materials in very sustainable net zero ways is the kind of vision of future that we're pushing forwards for. And again, once you have the ability to simulate the interactions between different materials in high resolution and with high accuracy, you can then start to search for new materials as well and find different ways of achieving the same outcome with different compositions, for example, batteries or any kind of material in that space as well. So that's kind of where our vision of where we'd like to go is kind of taking us. Again, it's a 3-5 year kind of plan, but in the short term, what we need to do is change the process that we have at the moment.
Because, and just remind me of this, the first instances of concrete, are they going back to the Romans?
Exactly, yeah, thousands of years, yeah.
And how much has it changed since then?
Not even, we've only recently discovered why Roman concrete was so good. So, yeah.
So it's about high time to start
Exactly.
reinventing materials.
Exactly, yeah.
And leveraging AI to really make that leap.
Again, the complexity of the problem is huge. Again, you can go down to atomic level simulation in order to kind of really understand what's going on in terms of why it has this strength and this kind of force of kind of connectivity. So it's understandable that we can very much struggle to build a first principles approach up, but simulation is really the key in terms of what we want to get to.
So let's hope we don't get flung into space by a comet to find that out. I think we just ran out of time, unfortunately. And maybe next time there's an opportunity to do that or to connect online and hear your thoughts on this. But for now, I think I would like to thank both of you. And thank you for the organizers and everyone. And please help me thank Aidan here for being here today with us.
Thank you very much, Matt. Okay.